This is June 2020, paper 51, and total marks defining the problem for setting up the variable is always 2 marks. Methods of data collection, which involves some type of diagram, procedure, method of analysis, that's 3 marks, which is the equation work. Additional details, including safety consideration, 6 marks. Now I'm starting with June 20, paper 51. Now this is the question. You can open in PDF also if you want. A student investigates springs made of metal wire as shown. A student constructs several springs from wire of thickness T. Each spring has a different cross-sectional area, capital A. In paper 5, everyone should always read the question 2-3 times before starting up any approach, because the reading is the main thing. If you approach the question in a wrong way, then it will be a very big loss, because a wrong approach is not given any credit. So he has a spring. Okay, the cross-sectional area is shown. The thickness of the spring, thickness of the wire is T. The student investigates how the spring constant K varies with area A. It is suggested that the relationship between K, it is suggested that the relationship between K and A is this formula. K is equal to beta rho into T4, A power 3 upon 2 into N, where rho is the density of the metal, N is the number of turns of the wire on the spring, and beta is a constant. Now read this page again and try to memorize it. So yes, have you read
So
it?
what is A?
Capital A is defined earlier. Capital A is the area, the cross-sectional
Oh,
area.
okay. Okay, got it.
Now, look at this part, read it carefully. Now, K is equal to beta rho into T4, A 3 power 2 N. Design a laboratory experiment to test the relation between K and A. Now, this is very important that this is very important whenever you are working on this title. These two lines, the green lines, are very important, because he is asking you to test the relation between K and A. What is K? You have to see that K, that suggested the relation between K. And that's basically how the spring constant K, spring constant is K, and A is the cross-sectional area. Then explain how your results could be used to determine a value for beta. Beta is a constant He said the procedure to be, these are always there. Procedure to be followed, measurements to be taken, control of variable, analysis, etc. Now, first heading comes in variable. Variable should be defined in the start. So give us side heading variables. Now, can you suggest me a variable? There are two variables, independent and dependent. So now
Yeah.
what I'm working here, A is the independent variable. I can change the area. Whatever you can change is the independent. K is the dependent variable. What is K? K is the spring constant. In this topic, paper 5, question 1, the most important thing is to remember what every letter means. You have to copy this.
Done, sir.
So variables defined. Now procedure. Method of data collection. It's normally a 4-mark section. It can be more than 4 if examiner wants. A well-labeled workable apparatus is needed. This is what examiner want people to remember. You have to write down a workable apparatus. Now, I will start my working. I have to remember everything from the diagram. Remember this concept that this is the diagram rule, and you have to develop a diagram. So how you will make your idea here, you have to see what every letter means. So whenever you are working for procedure, when you are working for the procedure, you need a mental work to find out every variable, everything which is going to be measured. Acha, then now look at this idea and let us start working. What is K? K is the spring constant. You have to start thinking that how you can measure spring constant. What is A? A is the cross sectional. A is the cross sectional area. N. N is the number of turns. You can even simply count it. This beta is a constant. What is rho? What this letter rho means? Rho is the density. Rho is the density. Okay. So rho is the density. Start thinking how we can measure density. What is T? T is the thickness of wire. This is my mental work and I start working on it. So now look at this diagram carefully, absorb it, and you need to make a plan to find out all these quantities. You need instruments for all of them. Method to measure mass or weight of load. So I'm putting a top pen balance for weight. How I can what I get if I use a Newton meter? We can measure the weight, right? Newton meter, Newton meter can be used to measure the weight, and top and balance can be used. Top and balance can be used to measure the mass. Okay. To determine thickness, I have an option of vernier caliper. I have an option of micrometer. Both are digital versions, and I can measure the thickness using them. Acha, this is my mental work. I'm thinking, and later I assemble all of them. How I measure the diameter of the spring? I can use vernier caliper. I can measure on different positions. Look, this is the diagram. Once I get the diameter, I can find the area. Area is equal to pi d square upon 4. This is how I can find the area. And then I can count the number of turns. This will be my n. Coil the metal wire to construct a spring. This is how we make the spring. We will have straight wires. We coil them. How we find the density of wire? Either use a table of values. What's the meaning of table of values? If we know the metal wire is copper, if we know the name of the metal in wire is zinc, if we know the name of the metal, then we can use that table value, or density is equal to mass upon volume. How we find volume? The wire is considered as a cylinder. Pi r square h, r is equal to d upon 2. Now look at this apparatus. This is Newton meter. My plan is to use this apparatus to find K. Can you recall from AS physics how we can find the spring constant using this apparatus?
By getting the mass and then
We put the load in the pen. We put the load in the pen. The pointer, the blue pointer will go down. We note down the extension. Look at, and we draw a
yeah.
graph between load and extension, and we draw a graph of different load and extension. The gradient of this graph will be constant, and it is the K. This is how we determine the value of K. Now, this is the procedure to mention. Now, what diagrams? You can make two diagrams in the exam. Other, you can write everything in the everything. Other, everything you can make. You can show the examiner in the script. So you can show. You can make two diagrams, because we have to find the diameter and we have to find the value of K. Acha, then diagram is always given as a separate section. Let me hide up this figure to a 12.1 so we can make a copy of it. Now, in your diagram section, I want to make two diagrams. One is this diagram, this one. One diagram I want to make which is showing how to find the area, and how we find the number of turns. And second diagram I am planning, the second diagram which I'm planning to post is the Newton meter apparatus. Okay, so you have to copy this, but you have in the paper, if the space is given is limited. So first you draw this diagram. So this is the diagram for the, now you take a wire and you will coil the wire to make a spring. Okay. Now, how we determine the density of the wire? We use a table of values or use density is equal to M upon V. You have to copy this also. So now we move to this apparatus. This is our main apparatus because it is going to measure the value of K. Our plan will be simple, that we will be actually posting different spring sizes. How we have a wire. Look, this is the wire. We will coil the wire on different diameters. We can make some bigger, I mean wider springs, some narrower springs, and then we can find the value. So copy this also. So this is the coiling of the wire. Now this is going to be the main apparatus to find the value of K. So now copy this apparatus. Now this is the apparatus and we will put different loads. For every load, we determine the extension and then we draw a graph of load against extension. I'm not narrating the procedure. I'm giving the procedure points. Procedure should be written in a continuous paragraph. Other areas should be covered in bulleting. Now here I will put different loads, and for different loads I will find the extension, draw a graph. So you have to copy this. This will also go in the diagram area. So this is the procedure. Now give the heading control of variable. This is a formal title.
Done, sir.
Now control of variable. Vary the age. So I will I will make springs of different cross-sectional area. For every spring, I will determine the value of capital A and K. Then obviously I will record the values in a table. Now you have to copy the control of variables.
Done, sir.
Now, analysis. What is analysis? Analysis is basically the type of derivation. So give the heading analysis. Now, this is the equation. I know that I have to bring K on Y axis because it is the dependent variable. A has to come on X axis. So first copy this. So that will be a starting memory.
Done, sir.
Now look at the derivation. I split it. I need to make a y is equal to mx plus c. I split it deliberately. K on one side, a separate because I have to make it the variable. Now copy this.
Okay, sir. Done.
Now, once you know that, plot a graph of k against 1 upon a, 3 upon 2. Relationship is valid if the graph is a straight line passing through the origin. How I know it should pass through the origin? Because the value of C is 0. So you have to copy this also in the.
Yes, sir. Done.
Now, rearrange for gradient because we need to find beta. Beta is equal to m n rho t4. Beta m is the gradient. So everything we put here to find the value of beta. In the start of the question, he had asked to find beta. Okay, you have to copy this.
Done, sir.
Now, precautions. Whenever you are working on precaution, you should remember there are two types of precautions: accuracy and safety. So make sure that the meter rule is vertical. Use a set square. And there are other precautions also. Whenever you're writing precaution, go to the apparatus. This is the apparatus. Make sure the meter rule is vertical. You can use a set square. You can also use you should take a number of readings for the area, for the length, for the extension, so you can take an average. There should be a little sandbag or cushion below the pen. So if the pen slip out, it doesn't damage the tile or the floor. Many other precautions can be written. They are happy if you write 2-3 precautions for safety and 2-3 precautions for accuracy. Accuracy and safety precautions should be mentioned. Now, what are these additional details? They are normally covered during the question. You're not supposed to give a separate heading. Avoid this heading. I mean, do not give the heading, but cover the points. These are the points which are given in marking scheme of this question. We have covered majority of the points, but you can read it and you can find if anything is missing. You can add in the question. I haven't dictated the procedure because I have discussed it in detail. Normally, normally you have to mention those ideas here which are related with the procedure, accuracy, safety. So this is the end of the paper. So this is the end of the paper, and we will continue inshallah in our next class. Allah Hafiz.
Assalamualaikum, sir.